Now these three different forms of learning. Right now we are focusing on supervised learning. So let me tell you what is supervised learning. It's simply like, let's say I know the temperature which is outside on, let's say, scale temperature, and I know milk production or milk demand, you can say. So for, let's say, 30 days, I have registered it or taken the samples. So 1 to 30, I have these values. So temperature, if temperature is 45, the sale is in terms of volume, we can say maybe 1,000 liters. And then if temperature is 42, it is 800, something like this. If temperature is 40, it is 700. If temperature is, let's say, 35, so it goes down to 600, something like this. So we can see there is some kind of a trend, or that as the temperature is falling down, the milk demand is also falling down. So, or it can be because we can also say it's for ice cream. So we can see that there's an underlying phenomenon over here. And can you tell what is a dependent variable? What is independent variable over here? You can write your answer in the chat box. What is a dependent variable and what is an independent variable? Which is governing what? Milk is the dependent variable, right? Temperature is independent, right? Vinith is okay. So here we can see that temperature is the governing variable, which is telling you how much demand of the milk will be. So we call it as an independent variable, temperature, and the milk we call it as a dependent variable. Now, so we can say, we can represent milk as Y, and X is your temperature. Okay, so we say there is an underlying function. That means Y is a function of X, right? So what we are trying to do is, if I know the value of the independent variable, can I find out the value of the dependent variable? This is the very simple thing that I want to find out. Okay, now I have, like in the previous slide, I had the data of, let's say, 30 days data I'm having. I want to find out in that 30 days, I want to find out, let's say now, that if the temperature is 32 degree centigrade, what will be the milk demand? Okay, and I can get to know about it if I have a function like this. Let's say it is linearly dependent on each other, or y is directly proportional to x, and there's a linear relationship between the temperature and the milk. Okay, so if so in this case, what I want is, right now I'm telling you the meaning of supervised learning. So in this case, what I know is that if I have this much amount of data, temperature and milk data, I will be able to find out the value for 32 degrees centigrade. So in a way, I need data for which is labeled. So we call x and y values as, x is your predictor variable, and y is your labeled data. That means for a certain value of x, you need to know y. Then only you can find out this function. Okay, so that's why we say these are labeled values. So I need labeled data to start with. So if I'm doing a supervised learning, I need labeled data. That means I need to have data which is having some points for which I know the value of dependent variables for given value of independent variables. I need that. Then after that, using it, I can frame an equation of my own, y equal to fx, or something, a straight line equation where c is the intercept and m is the slope that I can find out. Okay, so this is the meaning of supervised learning. So right now we are only talking about supervised learning. Now, before we even jump to find out the equation, there are few things which we need to do earlier. We've already talked about uh, data in, you can say, feature engineering, in which data cleaning we have done. We have analyzed the data in the previous sessions. We have done that. So after that, once you are done with that, I need to find out, even it becomes a part of that, where we made, I shared one uh, map, a sketch with you the other day, which was pair plot, in which all the variables, a scatter plot was made for between all the variables. So even before that, we go towards making an equation of, we also call it as a fitting an equation or fitting a curve between the dependent variable and an independent variable. I need to know, I need to make a guess which variables can have, which of these variables can have a relationship between them. So I need to have that one. So I can make scatter plot like this. Second, after scatter plot, I can also find out the correlation between the variables. Any idea what is correlation? Any idea? What is correlation? Anyone? You've heard about it. All of you have heard about it. You also use it in your day-to-day life. Okay. So correlation tells us what is the strength of relationship between two variables. Okay. Syed is saying the degree to which, yeah, this is a very good point, Syed. Degree to which variable depends on the another. It is actually a misconception. I think, Syed, you should also, and everyone should listen carefully, that correlation never tells you is there, what is the direction of the relationship, or which is the dependent variable, which is the independent variable. Correlation will never tell you that. It just tells the strength of the relationship between the two variables. So the direction of the causal relationship is not told by the correlation. So direction of causal means cause and effect. So causal relationship is not indicated by correlation. Direction is not related. So now, if on y-axis I'm plotting, let's say, temperature, on x-axis I'm plotting the quantity of milk consumed. Okay, so if these are the points which I'm getting, I'm not saying here that temperature is dependent on milk or milk is dependent on temperature. Although we have a general understanding, so we are able to comment that, of course, milk consumption is dependent on temperature, but the situation is not same in all the cases. For example, there are times where you are in a situation whether egg comes first or the hen comes first, right? So there are many situations like this. In that, the finding causal relationships often becomes very tricky, and so this is the scatter plot. And correlation is only concerned finding correlation only concerned with finding the strength of the relationship, and there is no causal effect implied in the correlation. Okay, this is one thing that we should be, but it does tell. So I'll share some figures with you. So you can see here, that yeah, so we have these relationships. Here we can see as x is increasing, y is increasing. So we can see there is a direct proportional increase in y. And the points are indicating a sort of a scatter plot. Is the line which is what we are trying to fit, or we are trying to find out this line. Okay. And there's an inverse relationship also, which is also linear. You can have curvilinear or non-linear relationships like these in the regression, and then you can have very strong relationships, and there could be weak relationships. So strong relationships, the points. Now, what are these points? These are the points for which I have taken the data, right? So x values and the corresponding y values, these are labeled values for which I have the data. If they are very close to each other, as we were talking, so then we can say that there is a strong relationship. And if I use this line to predict, the error which I'll be noticing will be significantly lesser. Similarly, we have weak relationships as well. Here we can see that the points are very much far away from the line. So the line which has been fitted between them. So we can say there is a weak. So the thing is that if you have the data x and y values, you're definitely going to get some value. If you apply the formula, it's not like the formula is not going to give you a line for an equation. Okay, it will definitely give you a line for an equation, but how representative is that line is the question over here. Okay, so yeah, now once we know that there is an underlying relationship, then we can go ahead with finding out the values of x and y. Okay, now let's take a small problem where we will be calculating the regression equation. I mean, we'll be using calculations, we'll find it out. So let's say I'm sending an image in the WhatsApp. This is the question. Here, what do you see in this? Can you tell what is this thing about? What are we trying to do? I've just sent you. Check your WhatsApp, and there's an image. how price of house varies with area. Okay, right. Or why it could not be other way around, that how square feet varies with the house price. Can it be other way around? How do we know that x is a dependent variable and y is an independent variable? Anyone? How do we know? Although it looks logical over here, you can clearly say that it looks logical over here, that house, of course, the larger the size of the house, or the larger the area the house is covering, the larger will be the house price. We can say that. Okay, so now how do we solve this equation, or how do we solve this problem? Let's say, before even we solve the problem, let's calculate the value of correlation coefficient. So I'll write the formula for correlation coefficient. This correlation coefficient helps me in finding out, we can say, summation x, summation y. You can take down this formula. This is the formula for uh, correlation coefficient. Now, what will this give me, and what information will it give me regarding that? Okay, Sayed is saying something. Sayed says, because some places have different rates than the others, so knowing the price, one cannot figure out the area, but for a given rate, know the price of a given area. So, Sayed, what is your? I mean, of course, I didn't. I think you mean to say that area could be the predictor for the price, but for a given rate, know the price of a given area. Okay. So, I mean, yeah, right now we can't just guarantee that whether x is y, x is dependent on or y is dependent on x. We don't know that right now. But we are just taking x and y for, you can say, we have to start somewhere, right? So let's take a house price as y and square feet as x. Okay. So we can do that. And let's do these calculations. So how do we do these calculations? So let's say, I'll, for the calculation part, I'll come back again with another problem. But right now, let's say we want to find out correlation coefficient. So let's say this correlation coefficient hypothetically comes around as 0.8. Hmm. I will again do the calculations, but right now let me come to the point first. So let's say for R value comes out as correlation coefficient comes out as zero point 0.1. Now this correlation coefficient actually can vary between -1 and 1. Hmm? So the more closer a correlation coefficient uh, is to 1, the larger it indicates that there is a significant relationship between, that there is a strong relationship between the two variables. If R is 0, that means, can you tell if R will be 0, what will happen to this? What kind of line would we get over here if R is 0? This is Y and this is X. If R is 0, then there would be no correlation. You might get a straight line like this, you might get a straight line like this, or there may be total randomness everywhere. So in that case, your R may be 0. And if you're getting R as -1, it will indicate an inverse relationship between X and Y. And if R is 1, then there is a direct relationship between X and Y. Okay. So R, this is the way R gives you the strength of the relationship. So once I know the strength of the relationship, I can go ahead and find out an equation bit. If it is 0, it is 0.1, 0.2. What is the point of finding out the relationship anyway? मजा ही नहीं आएगा. So कोई मतलब नहीं है if R equal to 0 or 0.1, 0.2. So generally it is considered that if your R value is greater, I mean it changes from situation to situation as well, but it's generally a thumb rule that if R is above 0.7 or below minus -0.7, then there is a good relationship between the underlying variables. Okay, this is one. Then so in this problem that we were doing, there is there is a sort of a doubt that X determines Y or Y determines X. So let's take a even simpler problem, or maybe much more forward problem. I'm sending you another image, which this is what we are going to solve for. So we are going to solve this by hand, and so I've just sent you another image. In that, you see that there is profiled customers and annual sales. So here the problem under investigation is that there is an April company, and their objective is to forecast the annual sales. So they want to forecast annual sales. Now, with this forecast, of course, why does anyone forecast? So that they can be better prepared for future. Okay, that is a very simple logic behind that. And you see they've got 14 stores, and they have an understanding, or over a period of time, the experts have said that the more customers you profile, means profiling means getting to know about your customer, or like KYC you do. Similarly, if let's say there are companies like Shopper Stop or Lifestyle, or like these stores are there. So if they profile their customers, like what are your likes and dislikes, and some questionnaire they give you and they get it filled. So uh, does profiling, so the question under investigation is, if I profile customers, will does it affect my sales? Okay, question one. And the larger I profile my customers, I can increase my sales by profiling customers or not. So, okay, this is the first question. Now, okay, if I do more profiling, मैं अपने customers के बारे में ज़्यादा information लेता हूँ. So, can I determine, अगर मेरा sales target इतना है, तो मेरे को कितने customers को profiling करनी पड़ेगी, या if I am doing this much profiling, what will be the annual sales? Okay, so this is the underlying question in this problem. So in order to answer this, let's try to find out two things. So let me write 1, 2, 3. There are 14 stores data. data of 14 stores is given. Okay, and there are few things which we will be calculating. Okay, so here first we will find out x square. So x, what we are taking is, what is x? Profiled customers. And your y is annual sales. Okay, so we find out x square, and because we'll be also calculating correlation coefficient, and after that we will be finding out the line as well. So I think in coordinate geometry you must have done this already, but anyway, so there are few things which we will be calculating. So I want all of you to take out your pen and pencil and notebook and start doing this by hand. See, there is a significant there is a significance behind doing it by hand, is that you will remember it forever and you'll get your concept engraved. So let's do this calculation. So for first point, 3.7, x square is 13.69. Please do that. Okay, tell me, keep telling the values in the chat box. What will be the second value for x square? Again, repeat that doing by hand is very important. Yeah, good, Shreyans. So keep doing it. 12.96. Then 7.84. Then 31.36. Then 10.89. Then 4.84. Then 10.89. Then 9.61. Then 10.24. Then 12.25, and so on. 27.04, then 21.16, and 33.64, and then 9.00. Okay, so for x square we get it. Now similar we get it for y square. So I'll write those values: 32.49, 34.81, 44.89, 90.25, 29.16, 12.25, 38.44, 0.09, 37.2, 24.01, 114.49, 57.76, 139.24, and 16.81. 16.81. Similarly for xy. So And do it for x and y and tell me summation x square, value of summation x square, tell me value of summation y square, and tell me the value of summation xy. Quickly do that. I'm waiting for your answer. Tell me these three values. 215.41, right? For y square, for y square 693.9, 693.9, very good. And xy, good Devansh, good Vikas. Yeah. Tell me xy now. I know there is no big deal in doing these calculations, but then it keeps you connected with the data. So that's why I'm asking you to do it by hand. After this, you'll be anyway using Python. So summation xy. 382.85. Good Vikas. 382.85. Now, once we've got these values, next is we need to know how to find out value of r. Now, quickly tell me the value of r for this one. I think there's one additional term which you need to find out. Summation x, summation y, and yeah, summation x, summation y. So tell me the value of r with this formula. Here n is 14 and summation x, okay, I'll write that as well. Summation x is 52.9. Summation, I'll again write all these values, just clear it. So yeah, summation y is 92.8, and from the previous slides we have got summation x square as 215.41, summation y square as 693.9, and summation xy as 382.85. Right. Then what else do you need? I think you have all. Now tell me the value of R. Correlation coefficient value. Please calculate the value of correlation coefficient. Oh, I think 0.9. Yes, I am presenting the screen. Other people, are you able to see my screen? I think yes. I think you need to go to. I'm logged in from two different places, so you need to check in the other one. Check in that. Vineet is saying 0.92 is the value of the correlation coefficient. 0.92. Are you able to see it now? Because yeah. So I am actually logged in from two different machines, so that's why uh, the presentation, the slides are coming on the other one. You can see that. So are all of you getting 0.92? How many of you are getting 0.92? Say yes if you're getting 0.92, or if you're getting any other value, let me know. Sayed says yes. Tina, good. Puneet, good. Okay. Shreyash, yes. Okay. Vikas is saying yes. Nitin is saying yes. Abhinandan, yes. Okay, good. So now we got this value as 0.92, which indicates a very high correlation. That means there's surely a link between the profiled customer number of profile customers and the annual sales. Okay. Now after this, once we have established that, we can go ahead and find out. Just a second. I need to add more slides. Okay. So now the next thing is we will be finding out um, SSXY, sum of squares XY. We will be finding out sum of squares X, and we will be finding out sum of yeah, mainly do these two things we'll be finding out. Now, what does it mean SSXY? It means that the formula. I'll write the formula. See, I'm not going in the derivation part of this because then again we'll be actually studying statistics rather than your machine learning. But then some basics which you need, I will keep on telling you as the time progresses. So SSXY in a way represents the variation or the deviation of your ऑब्जर्व्ड वैल्यूज मींस जो आपने वैल्यूज आपके टेबल में है, इंडिविजुअल वैल्यू का मीन से डिफरेंस कितना है. ओके, सो एंड दैट SSXY represents the total variation which exists because of X and Y, and SSX represents the total variation which exists because of X, which we have taken it as number of profiled customers. Okay, so it represents that. So a variation, this is accounting for variation SSX and SXY. So can you calculate these values? If they are further simplified, if these formulas are further simplified, they can be written as summation xi square minus so this SSX can be represented by this formula, and SSXY can be represented by another formula. So is it clear, these two formulas? So SSX and SXXY we need to calculate, which indicate the variation because of X and Y in the whole model, and SSX means the variation just because of the X. Okay, then after that we calculate the intercept and the slope. So your B, I mean what we are trying to find out is y equal to uh, y equal to B1 plus B naught. Just a second. What we are trying to find out is an equation for y equal to B1 x plus B naught. This is what we are trying to find out. Okay, so your B1 would be uh, given as SSXY divided by SSX, and your B naught will be given by, I mean once you find out B1 you can substitute uh, y bar and x bar, so that can be mean of y minus b1 x bar. So with this you can find out b naught and b1. So let's calculate SSXY. Tell me the value of SSXY for this problem. Please do the calculation. I hope you people are doing the calculation. Tell me the value of SSXY. Very good, Shreyash. 32.198. Are other people also getting it? Are other people also getting it? SSX is Devansh, SSX. Probably I think you need to look at it again. SSX की value तो ठीक नहीं आ रही है. But SSXY is right. So SSX की एक बार बाकी सब भी calculate करेंगे. Okay, sorry, I forgot to put square over here. Now you can do the calculation. SSX 15.52, right? Right, Devansh. So that's coming out. I'll write it over here. 15.523. 15.523. Good. So now we can. Next thing is we need to calculate B1 value. So B1 value is. Let's calculate B1 value. I can take out these formulas from here now. I think you've already done with that. So B1 and B0, both values. B1 is 2.07, right? 2.07. And B0? Good, Vikas. Good, Sayed. Calculate B0 value. Abhinandan, you've raised hand. You want to say something? Okay, B0 is minus 1.20. Good. So with this, we have been able to find out the equation. Now, what will be the equation? The equation will be y equal to 2.07 x minus 1.2. Now we've got this equation, but we need to be careful while we are interpreting it. It's like if x is 0, what does that mean? That means if I don't profile any customer, that would mean what? If I don't profile any customer, that would mean that I will be making negative sales. I mean, that makes no sense. So at times you have to be careful while you are interpreting the equation. It is still an equation only. It is still a mathematical abstract representation of the situation, and not the physical law, right? Okay, so now there are other issues associated with this equation. Let's understand those issues. Y equal to 2.07 x minus 1.2. Okay, now for the same data, for the 14 store data, 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14. Can you tell me now? Let's represent it by y hat. Y hat means it is an estimate of the, it's still an estimate. Why it is an estimate? Let's see. So according to that, let's some space is less at the top. So I'm going to write it like this. Y hat. Can you calculate y hat for all the 14? Just calculate y hat for all the 14 stores. Amar. So calculate y hat values for, then I will tell you why it is an estimate. Calculate y hat values for all the 14 stores. Okay, tell me the first value. Tell me the y hat value for the first one. 6.459. 6.459. For the second one, 6.252. 6.25. 4.596. 4.596. For the 10.392. 10.392. 5.631. 5.631. Sixth. After that, yes, Vinit. After 5.631.
Sir, doing.
Hmm. 3.354. 3.3. Then 7. 5.631. Then the eighth one. Other people can also tell. 5.217. 5.217. For the ninth one, 5.217. 5.424. 5.424. Okay. For the 10th one, 6.0. 11th, 6.044. Okay, so 6.0.
6.045.
Okay, let it be 6.04. Then 8.322. 8.3. 13th and 14th. So 10.8. 806, and then is 5. Now we can compare y hat values with y values, which were actual values. So there, y hat is the estimated value of y, and capital Y, or you can say annual sales is, sorry, just a second. Okay, so if we keep those values over here, this is 5.7, and this is 5.9, and this is 6.7, and all. I mean, I need not write that again. You can also compare these values. So what we see are that these are not the same values which we have predicted. Had this had this equation been true, the values which we had predicted are not exact. Can anyone tell why these values are coming out to be different?
So we have considered only one factor, but the values might be dependent on various factors.
This is one, of course, we can say that, but then uh, even let's see,
We don't have an exact relation between the two variables.
this line is not passing through all the points. Very simple reason is that the line which we have drawn is an estimate, is an abstract representation of all the points. Okay, or it's all points are not lying on that straight line. So what is this thing actually? So we are now coming to the point, trying to understand the meaning of regression. So let's say I draw this line. uh, okay, it's negative intercept hai, so let's make it like that only. So yeah, so let's say your line is somewhat like this. Is your minus 1.2, minus 1.2 over here. Okay, now with this minus 1.2, this is the line which we have drawn with the slope 2.07. Let's take 1.5.7. Okay, so for a given value of x, that is 3.7 customers. So let's say this is 3.7 customers we talk about. And there are 2 points basically. So I'm changing the color. So if I extend this line, there is 1 point over here. The value of this point will be, can you tell me the value of this point on y-axis? What will be the value of this point on y-axis? What will the value over here where I made the cross? Yes. What is the value of this point which I made over here? 3.7. Anyone? I'm surprised no one is telling.
6.46.
6.459.
No, you don't have to calculate. Yeah. Okay, we had already written. So this is 6.459. 6.459 is the y hat value. Okay, this is y hat. And where does our actual value lie? 5.7. I'll make it with a different color. So this is 5.7. Getting it? So now if we extend it, this difference that you see over here, okay, this difference is what is significant, and this difference what we see is a residual. We say it's a residual error. Similarly, this residual error will be present for all the 14 points. Yes or no? right? Now this residual error which I'm talking about, this actually makes the whole sense of the situation. So yeah, just a second. So we say, and let's say we draw a mean line also. For y bar, we draw a y bar as well. So let's say that we represented by yellow color. Let's say this is your y bar. Okay. So now you have mean line y bar, and this is your estimated line. We can say y hat. Okay. And total sum of squares. That means your actual value is the blue point. This yellow line over here. So I'm taking off this table now. I think we don't need it. I'll be a bit slow because once you understand this concept, you will probably be benefited for life. So we say this thing as SST, that is total sum of squares of the errors. SST, that is, how do we find out SST? We find out the average and then individual point, the difference of individual point, which point? The actual observed value. So SST we say is given by summation yi, that is the individual observation, minus y square. Okay. And there is a reason why we are writing these formulas. I'll come to that. And then SST we write, which is you can say is y hat and y. So this is your SST, SSE, error sum of squares, which is a sort of we can say it as yeah, Devansh, you're right, sort of loss, but loss function is actually used in the terminology of loss function is used in a different aspect. It's used in Taguchi function. So we're not talking it as, we're not naming it as loss function, but as residual. We say it as residual. So SSE. So SSE is summation yi, that is the individual observation, minus yi hat square. Yi hat is the estimated value for that individual observation, for that particular observation. And SSR is the next one we find out is SSR is the difference between the estimated value and the mean. So we can say the estimated value, and this is your SSR, residual sum of squares. Okay, so we say it as residual sum of squares, that is yi hat minus y bar. That is how deviated are your estimated values from the mean value. So these three parameters, SST, SSE and SSR, they will tell me how good is this equation, because again I repeat, we will always get the equations as long as there are values available with me. As long as there are values available with me, like I've got a table, I can make any random table. I can without even taking observations for anywhere, I can take two columns and fill values in that, and I can find out the regression equation. But is this equation valid or not? How do I know that? In order to know that, I need to do these calculations. Why are we doing these calculations? We are saying that we are trying to say that how much variation in x leads in how much variation in x explains the variation in y. If my model, if my equation is able to explain all the variation which is coming in value of y with the help of all the variation which is coming in value of x, then we say x is predicting y. Okay, so ये इसी तरीके से है कि you look into your reflection in the mirror. So if you raise your hand up, your hand will go up, right? Now, how good that mirror is depends on many physical factors of the mirror. So if there are inconsistencies in the mirror, if you raise your hand, and then your hand will be reflected to be raised in that mirror, but by what angle and by what in what true sense is your hand being reflected in the mirror. ओके, सो जितना ज्यादा वो अच्छा फिजिकल प्रॉपर्टीज होंगी, जितना अच्छा बना हुआ होगा वो मिरर, उतना ही वो रिफ्लेक्ट करेगा आपको. सिमिलरली जितना अच्छा आपका मॉडल होगा, जो इक्वेशन है आपकी जितनी अच्छी होगी, उतना ही अच्छा वो y को रिफ्लेक्ट करेगी. x की वैल्यू का रिफ्लेक्शन y में होता है, इट्स इन अ वे. तो उसका जो वेरिएशन हो रहा है, x का वेरिएशन अगर y में भी इनकॉर्पोरेट हो रहा है सारा, then it is supposed to be good. Now, with this, what we want to see is that I want to find out value one with use of these formulas. I want to get one measure. This measure is called coefficient of determination. We say it is r square. I'll change the color. We say it is r square. Okay, it is a very common term which you will always see in the outputs of regression, r square value. This is called coefficient of determination. Coefficient of determination. This r square value is ratio of SSR by SST. Okay, this value is SSR and SSR by SST, and it lies between 0 and 1. So if your r square value is higher the r square value, better your model is. Better your model means you can look it from that point of view. SSR means जो variation है because of the estimator y. Okay, so जो estimate की वजह से जो variation आ रहा है, total variation, मतलब total variation का कितना % आपका predictor variable x बता पा रहा है. So if this value is let's say 0.9, what it will mean that 90% of the variation coming in y. I'll write it. 90% of the variation coming in y is explained by x. That means 90% of variation जो सेल्स में जो 90% ऑफ वेरिएशन आ रहा है, सेल्स में जितना भी वेरिएशन आ रहा है उसका 90% इज एक्सप्लेन्ड बाय द वेरिएशन कमिंग इन नंबर ऑफ कस्टमर्स प्रोफाइल्ड. ओके, सो ये तो बहुत अच्छा है. मतलब 90% एक ही वेरिएबल ने 90% आपको इतना उसका वेरिएशन एक्सप्लेन कर दिया है कि इट इज अ गुड मॉडल. तो बाकी 10% का क्या हुआ? कैन एनीवन टेल बाकी का 10% का क्या हुआ? बाकी 10% वेरिएशन का क्या मतलब है जो हमने एक्सप्लेन नहीं कर रहा है? एनीवन? कैन एनीवन टेल कि बाकी के 10% को हम क्या करेंगे? मतलब व्हाट डू वी से अबाउट द रिमेनिंग 10%? So for the remaining 10%, what we say is it could be because of the random error. Random because there's a natural variation present everywhere in this whole universe. There's a natural variation, as I talked about earlier also, that even if you try to do the same thing again, you cannot get the same results again and again all the time. I did give you an example of a fielder, and he's trying to is trying to make some person run out by throwing on the wickets, and every time he'll not be able to hit the wicket, even though he tries. If we do it for 100 times or 1,000 times, so it's not possible. Okay, you can say 10 out of 10 could be possible, but as you increase the size, if you try to generalize it forever, he will be able to repeat it. It will not be possible. So the remaining part of the error, that is 10%, could be because of the natural variation or the random variation, or it could be because of other factors which I have probably not included, like the amount of investment on marketing, which will also affect your sales, right? It's not only profiling of customers which is increasing your sales, it could be other factors also. So I'll share a screen now. So you don't have to worry about this complete thing which is visible, but I'll tell you, this is an output which comes in a statistical package, SPSS. This is an output of SPSS which I'm showing you, because you often get many different types of output when you run in regression, but uh, I'll tell you some thumb rules. I'll not explain you everything because you're not in a position to understand everything over here. But right now, what you understand is R square value. For this particular model, the R square value is coming out to be 58.808%. I mean, or 0.58. So, which is saying that only 58% of the variation. Okay, this is the one for house pricing. Let's say this is वो house वाला जो मैंने आपको data दिखाया था उसका output है. So we say that 58% of the variation coming in house price, coming in the land size, is governing the is price of the house. There are other factors also which govern the price of the house, like location of the house and infrastructure in that area. So there are many other factors also. So that's why only 58% is explained by that. Okay, you will also find these values like significance, FP values. There we call them as P values. ये अगर 0.05 से बड़ी होती है value, so we say that our model is significant. और अगर ये I mean it indicates के linear relationship है x and y के, क्योंकि इसमें आपको कई चीज देखनी है. आपको देखना है कि वेरिएशन कितना एक्सप्लेन कर रहा है, आपको ये भी देखना है कि रिलेशनशिप लीनियर है या नहीं है. So if the relationship is linear, this value will be greater than 0.05. So it is less than 0.01. So it indicates that possibly the relationship is also not linear. Okay, you see here, it's indicating p value only square feet. It is written aside square feet. So t stat and p, you're not in a condition right now to understand the significance of p value, but for now you can just consider कि इसकी वैल्यू 0.05 से ऊपर होती है, बिकॉज आपको उसके अंदर फिर इन्फरेंशियल स्टैटिस्टिक्स पढ़नी पड़ेगी. सो अगेन दैट इज नॉट पार्ट ऑफ द कोर्स. सो एनीवे, सो ये 0.05 से अगर बड़ी होती है p वैल्यू, सो इट इंडिकेट्स दैट या uh, that there's no linear relationship between x and y. So probably this model which we have fitted, this called model fitting. जो जो भी हमने किया है, हमने एक डेटा को एक फिट किया है, स्ट्रेट लाइन पे फिट करने की कोशिश करी है डेटा पॉइंट्स को. So we say it is model fitting. So the model which we have fitted does not seem to be good enough. Now इसके अंदर अगर हम और वेरिएबल ऐड कर देते हैं, दो दो कॉलम और ऐड कर देते हैं, उनकी वैल्यूज भी डाल देते हैं, वी कॉल दैट एज अ मल्टीपल रिग्रेशन. सो वी आर नॉट डूइंग मल्टीपल रिग्रेशन नाउ. आई विल ट्राई टू कीप थिंग्स सिंपल. सो आर स्क्वायर की वैल्यू सभी को समझ में आ गई होगी. राइट नाउ दिस इज व्हाट इज इंपॉर्टेंट फॉर अस. ओके, नाउ लेट्स से I'll try to run it in Python and tell you. Let's take the another type of data. Just a second. So let's take the challenger data. I'm sending you the challenger data by WhatsApp. All of you got the challenger data? Say yes if you've got it. Say yes, you got the challenger data. So I'll just open this. So this is Space Shuttle Challenger disaster. Okay, it happened in 1986, and some, you can say, launch and failure, decision to launch. So here it is. We try to find out why it did fail. So see here, just read it. Solid rocket booster O-rings. So these are O-rings. You can see in the data as well. If you look at the data, there is one column of O-rings. O-ring fail, 0 and 1. So you can use some filters to see. So O-ring actually a type of an, you can see here what is the purpose of the O-rings. So O-rings were required to contain the hot, high pressure gases produced by burning solid propellant inside the SRB, solid rocket boosters. Okay, and if this O-ring, can you tell if this O-ring fail? I mean, you don't have to go into the rocket science, but अगर ये ring fail हो जाती है तो क्या होगा? Hot gases produced will leak, right? Which which will lead to some kind of disaster. Okay, so here uh, probably you might also find out cause and time. Two cabin was reinforced and detached one piece of rest of it. The cabin detached in one piece from and traveled, reaching in speed. At least some crew was alive and living. So here they say that it may be because of the loss of the pressurization. So basically, this is a real incident, and uh, the parameters which were responsible for the failure were temperature or and pressure and O-ring. I mean, by looking at this data, we would like to know that what is the condition of O-ring when the temperature and pressure vary. Okay, so if the temperature is of this value, what will happen to the O-ring, whether it will fail or not. So these are the lessons which you actually learn from the past data and try not to replicate the problem. Now this is the data which we are using. So I'll load this data. Anyway, in the practical class, you will be doing this, but I'll do some demonstration. So I'll load this data first. I have to open the project. Okay, the file is loaded. Now, let's see. I would like to find out the correlation between so with this, I found out the correlation between all the variables. So data, I call the data frame, I mean, the variable which is defining the data frame, and CO double R. CO double R is the command for correlation, and it is available in the pandas library. So you see by looking at this, can you what can you tell? Are you able to see this output? By looking at this correlation matrix, what can you tell? Yes, guys. Have a look at this correlation matrix and give your comments on the same. Is it visible to launch ID and pressure has maximum correlation? Okay, 0.83. But does that make any sense? What sense you? It will give you some value definitely. Another, I mean, it doesn't make any sense. You can have 100 different variables and find out the uh, correlation, but then uh, temperature and ring failure. Yeah. So we say there is a, so what kind of relationship is there? Negative relationship or a positive relationship? Negative. So that means lower the temperature, the chances of failure of uh, O-ring is higher. Okay, 1 and 2, it is in the data you can see number of O-ring failures. So 1, 0 failure, 1 failure, 2 failure, it is like that. This is one thing. So of course, now we can do few other things like we can now here look at this command over here. We find the ordinary least square method, OLS. So the formulas which we have used in for calculating B naught and B1 value, those formulas we got from the derivation behind that is ordinary least squares method, which where we try to minimize the error. Okay, so ordinary least squares method OLS has been used over here, and the command used using odd. So here you can see statmodel.api is the package, and SM we call it, and in that we call which there are other maximum MLE also, maximum likelihood estimate method is also there, and OLS method is there. So we have used OLS method for regression, and the dependent and the independent. So first we write the dependent variable, that is O-ring failure, and then we write the temperature, that is independent variable, and dot fit, that means fit the equation using the OLS method, ordinary least square method, and then model dot summary. So you give the summary of the model also. Okay, I did not run the whole command. Okay. So let me run it completely, run the whole model once. So when I run this particular, yeah, just where did it go? When I run the model summary, yeah, I get this model summary. Okay, I'll undock it and explain. So this model summary which I get over here, you see the kind of, I did show you that presentation also. In that we are getting this R square value is very small. Okay, so the model is not very good. We can say that it's explaining only 17.8%, and it's you may not worry about adjusted R square right now, because Adjusted R square is used when we are having multiple correlation. Then more than one independent variables are there, then we consider adjusted R square. Right now we are just talking about R square value. That's 17.8% only. So that is also not a very good indication. And p value also we can see. Where is the p value for this one? So 0.04 is indicating that it is not that linear as well. I mean, it should be greater than 0.05 to indicate that there is a linear relationship between O-ring failures and the temperature. So it is showing that, okay, it's not linear as well. Okay, so these are two things which you can see in the model summary. For now, I mean, you're not an expert in statistics. I can take that, but then that's a totally different course on statistics if you have to understand all these values which are written over here. Okay, now this is one thing. So we can see here that the model has not been good enough. So whatever we have learned today is part of this. Other than that, we can also make pair plots like we've done it earlier. So Seaborn is another package which lets us make these pair plots. So you can look at that in the plots. So you see here pair plots. Okay, heat map was also there. Okay, I think this is also another good plot which we can see, SNS dot heat map. So SNS comes from Seaborn, and heat map is what we are trying to make, and these are some parameters of heat map which you can always Google and find out, or even Amit will tell you later. So let me run it and give. This is another very good tool which is available in the Python. So you see heat map over here. It also indicates the correlation. If you don't want to look at the values, because comparing the values becomes a bit difficult and time consuming if the number of variables are large. So you can look here. The darker the region, uh, we can see here like O-ring failures and temperature was indicating higher correlation. Okay, and launch ID and there was another one. No, what was that? Launch ID and pressure so were also, but then yeah, I don't know, but yeah. So the correlation is higher. So darker the region, it is called heat map. So darker region represents higher correlations, and lighter regions represent, like here, O-ring with O-ring is very light, so you don't have to actually look, give your attention. So darker region represents areas of higher attention. Okay, then mostly now after that there's this part which I have not talked about yet, which is splitting the data into training and testing, because it's the supervised learning that we are doing. So I will also talk about this in detail tomorrow, about how do you split the data, how do you sample the data. That part is I've not taken, because if I had taken it earlier, you would not understand much. So if I have to find the relationship between X and Y, anyway, we have run that earlier. But then before you run, you have to actually do the proper, that was not machine learning, which we have done earlier. Like predicting the value of Y, that was not the machine learning part, that was the regression part. And if you have to apply learning in regression, then you have to split the data into two parts. For splitting the data, sklearn package is used, and import train test split. This is the function which is inbuilt, and xtrain x test xtrain. So this is the sequence which is used. First you write train and then test, first independent variable, then the dependent variable. X and Y. Train test. Then train test split is the function which we'll be calling for X and Y values. Here it is given test data size is zero point 0.4. That means 40% of the data will be used for testing. That is 60% of the data. So we had how many rows over here? We had 24 rows. So 60% of 24 is around 14 or 14 to 15 observations will be used for training, and the remaining will be used for testing. Okay, and random state one, we talk about that later. So we'll print the data which we have split it for training and testing. So you can see here it is how many 1 2 3 4 5 6 7 8 9 10 11 12 13. So 13 values are for training and for so you can see here for 73 it is coming out to be 0 Y value. So O ring failure. At 73 no ring failure. At 70 there is a ring failure, but again at second value there was no failure. So that's how your model works. It's not like for one value of 70 it will give 1, and for another value of 70 it will also give 1. So that's not necessary. So this is what machine learning is. And here you see for 67 it is giving failure. So in a way, for lower values of temperature it is giving failures, but it is a training data. So you can also print the testing data. I can write it over here, print test. So here we can print the testing data, and let's see what does it give. Y underscore train. So this is your testing data, which is 1 2 3 4 5 6 7 8 9 10. So that is your 40% of data is for testing. So these are your testing values, and we can also print Y train data, Y X test data. Now what does it indicate is that initially, well, just undock it. So initially these values were used for training your model. Training your model means getting those values of B0 and B1. Okay, and the best values of B0 and B1 were using OLS. They got it, and then we test it. So for 75 it is giving 0. So let's see if there is in test data, in training data also, is there a 75? Yes, there is a 75 over here, and this is 1 2 3 4 5 6 index. 1 2 3 4 5 6. It is giving 0. That is no failure. And for this also it was giving no failure. That means in training and testing you're getting the same value. Now let's see, this one is giving 2 failures for fourth one. 1 2 3 53. For 50 temperature 53 it is giving 4 failures. So is there a 53 over here? We don't have a 53, but we have the closest to one. 53 is 57. So 57, 57 is 1, 2, 3, 4. From the bottom, we have one failure. So you see here, it is not perfect, and which is also indicated in the R in the model fit indices that R square was 17% only. So it is not that good model anyway. Uh, can we improve it? Probably we can improve by changing. We can change zero point 0.4. We can take it as zero point 0.2. Okay, and let's run it again. So we that is 20%. We again see it. Now you see that training data has increased. There are more values in the training. So let's we can find out the shape also of the mm, it's on this. 18 is to 1. So now earlier there were 13 or 14 rows in that. Now we have 18 rows in it. So 80% of the data is used for training. And does it improve our now how I can do that all the time? No, it's not a good way of doing that. I check the values were correct values or not. So I can calculate the accuracy of my model. So I can do that. I can also get the equation. So let's do that. Now you look at that. Accuracy of the model is 37%. So if I change it to zero point 0.4, this is called hyperparameter tuning. When I'm changing the test data and all these, no. So I'm changing these values and I'm going to run it again. The accuracy has increased. Now it is with 0.4, it is giving better accuracy. Okay, and the slope is minus 0.05. Now you must be wondering that I should get same slope all the time. Should I not? If I change the sample size, should my slope change or not? Let's go and see at the top. What was the slope which I was getting earlier? I was getting slope minus 0.04 and now the slope is minus 0.05. Why the slope is changing? Can anyone tell? Why the slope is changing when I'm changing the test size of the test data? Because earlier I was using 13 observations to calculate the slope. Now I'm using 18 observations to calculate the slope. So obviously it's going to change. I can also use it to find out for given value of x, what will be the value of y. So if the value is 30, what will be the value of y? So we can say we can completely use this and yes. So for 30, for new temperature, the predicted O-ring failure is 2.31. So right now we are not running a discrete model for the discrete value of y. In linear regression, we are assuming that x and y are on continuous scale. So any doubts in today's lecture?
Excuse me, sir.
Yeah, Vineet.
So when we increase the test size, the accuracy got increased. Shouldn't it be opposite of that?
Actually, the problem over here is the sample size we have taken is very small. For 25, it is not. You can't run a machine learning algorithm on 25 sample size. 24. I mean, not even 24, 23. So, although we are running machine learning algorithm on 23 sample data, it is not advisable at all. You need large data to observe that what you are saying. That observation, the generalized observation can only be done when we have large data set. We can do that later. Right now we are learning only. So you can do this all this experimentation. But right, you are right. As the training test data should actually improve your accuracy. Okay, because you have more samples, and we will talk about it. Accuracy and all these things are very important, and there'll be separate lectures on these performance parameters of machine learning algorithms. Right
Okay.
now we're just starting with the understanding of machine learning right now. Getting it? So I hope I'm clear, Vineet.
Yes, sir.
Anyone else? Okay, that's it for today. Tomorrow, uh, I will take a different topic. Today we are doing linear regression. So tomorrow maybe I'll take this one part of model selection which is left, which should have been done earlier, but you need to know what is machine learning before we take that. So that's why I've taken linear regression, which is the foundation. Okay, so yeah. Tomorrow we may take model selection part, which is very important. And in
So will there
afternoon,
be any other class?
yeah, afternoon you'll have those practical sessions. Okay.
So, at what
Please
time?
link.
uh,
At what time?
2 o'clock.
So can you please share the attendance link?
Yeah, I'll send that. You have that attendance link? I think it must be lost. I'll send it. I'm sending it in the group.